Hello, everybody, and welcome back. Or I should say, I am back. I am back. Um, man, it's been like 10 days, and it has not been a good 10 days, I'm gonna be honest. First was moving, then kind of caught the flu after that. Definitely a 2 out of 10 would not recommend. Have a bunch of stuff to make up. Anyway, that's not the point. Um, the point is, you're looking at this channel because you're looking at a whiteboard because this is a math channel, and not my face because this is not a vlogging one. Anyway, getting on to the actual math, we have this nice integral today. It's the integral from 0 to infinity of 1 over 1 plus e to the x to the n. So Gaussian-like in a way, we'll end up, well, you'll see where it goes. Anyway, it's really fun. So the first thing I'm going to do is really just rearrange this integrand. So we're going to just have, let's see, the integral from 0 to infinity, still, no u subs yet, of e to the minus x to the n dx over 1 plus e to the minus x to the n. And you might remember from calculus that the sum of some x to the k is this just equal to 1 over 1 minus x. And basically that just means we can express this little denominator bit right here just as an infinite series, integrate it, and then kind of left with the sum, but you'll see where that leads. Anyway, so yeah, I'm just going to express this as an infinite series and see where that takes us. So we're going to have the integral from 0 to infinity of e to the minus x to the n of the sum from k equals 0 to infinity of minus e to the minus x to the n all to the k. And just by properties of exponents, I'm going to bring the k inside of here, and then pull the sum out, reverse the order, because we can do that, and we love to do that. So we're going to have, what kind of sigma is that? I've already made fun of my sigma's already made fun of already. I can't be drawing them like that. Jude. Let's see. Negative 1 to the k of the integral from 0 to infinity of e to the minus x to the n. And then what we have here is just an e to the minus x to the n to the k, or times k. And we're multiplying these two things. So by properties of exponents, that's just a 1 plus k, or just factor it out, really, dx. And you'll notice this looks a lot like the Gaussian, which because it essentially is, actually. So, it's a little tiny, u sub. We're going to let u equal 1 plus k to the 1 over n times x, of course, and that means our du is equal to our dx, just with an extra factor of 1 plus k to the 1 over n thrown in right here. And then, just subbing that in, there should be an x there. We're left with the sum from k equals 1, or sorry, 0, we haven't reindexed yet, to infinity of negative 1 to the k over 1 plus k to the 1 over n times the integral from 0 to infinity of e to the minus u to the n du. And this right here really just is the generalized version of the Gaussian, which is really cool. I'll just show you why it's cool now. We're just gonna do another u sub, so we're just gonna let v, I guess. I don't like doing double u subs, yeah, but we'll do what we gotta do. dv equals n u to the n minus 1 du, meaning that our du is just equal to 1 over n times u to the 1 minus n dv. But let's kind of look at this a tiny bit closer. You'll notice that we have a u here. I'm just going to sub that in for, put that in terms of v. And u is just v to the 1 over n, meaning that we just take this, take it over n, and that's a v now. So we end up getting 1 over n times v to the 1 over n minus 1 dv. And let's see. Still integral from 0 to infinity, bounds have not changed, of 1 over n times v to the 1 over n minus 1 e to the minus v dv. And you'll notice that this is just a gamma function. It really is. Well, this bit right here is actually the gamma function. We have an extra factor of this right here. So, I mean, I'll kind of write this out more clearly. We have 1 over n times gamma of 1 over n. But, you know, by properties of factorials in the gamma function, this right here is just, by definition, 1 over n factorial. So now that we've completed our fun little side quest of showing that the generalized version of the Gaussian is just 1 over n factorial, we're left with an infinite sum. So we have a 1 over n factorial. I'm just going to put that up front. Times the sum from k equals 0 to infinity of negative 1 to the k over 1 plus k to the 1 over n. Now, this little thing right here might look familiar to some of y'all, or not. I don't know. But this right here is this just the eta function of 1 over n. Which is really cool because, I mean, it just allows us to express it as a nice combination of functions. So, our total integral here actually just equals eta of 1 over n times 1 over n factorial, which is really cool. But I don't really want to leave it there. And the reason for that is because I actually gave this integral to my friend, not the not the generalized version. She's only taking BC, but I say only. It's pretty. Anyway, you get the point. If you let n equal 1, you can actually do this by a nice little u sub. So basically, if you let n equal 1 and do a u sub, you should get the answer. But I mean, we also have this nice formula here, so I'm just gonna, you know, I'll just a different color actually. We're gonna let n equal 1. And, well, we have what? Eta of 1 over n times 1 over 1 factorial. But this right here, well, it's just 1. So we have eta of 1 of 1. Now, that might be like, some of y'all might be thinking, well, how am I supposed to know eta of 1 is? Well, it's just an infinite series, just this right here. So I'm just going to plug in 1 for n, and what we're going to do with a little re-indexing, of course, we're going to end up with k equals 1 to infinity, negative 1 to the k, minus 1 over k. Now, oh, they haven't gotten there in BC. Oh, it's the next unit. Oh. Y'all see this next unit. Anyway, this is really cool. This is just the alternating harmonic series. Basically meaning, this is just the natural log of 2. That's all it is. Will I be proving that right now? No, I will not. But it's still a really cool fact, and yeah. So the integral that I originally gave my friend was n equals 1 is just natural log of 2. So it's kind of a convoluted way of getting there, but kind of more fun in my view. That's just my opinion, though. Anyway, thank you all for watching. I've rambled on for too long already. So yeah, I'll see you all in the next one. Thank you for watching.